Alright, calculator problem 8A. Here's the deal. For whatever reason, didn't really like this problem that much last year, but I'm in love with it now. I think it's super cool. I think it's super useful. I think it's good conceptually, and it does a good job of bringing geometry into what we're studying here in pre-calculus. So I'm super excited to be making a video for this problem. The length of a rectangular box is 3 times the width. If the volume of the box must be 320 centimeters cubed and the width is x, express each in terms of x. Then we want the width, the length, and the height. So I'm a visual person. Maybe some of you are as well. So I'm going to draw myself a little diagram, because diagrams always make things more understandable, at least for me. Maybe you feel the same way. And I'm going to label this with a side length of, ooh, that's not the shape I wanted to do, with a side length of x. I'm sorry, I should say a side width of x based off of what these things say. A length of 3x, because the length is 3 times the width, so that's going to be 3x. And then a height of something I don't yet know. But here's what I do know. I do know that the volume has to be 320 centimeters. And if you think about the formula for the volume of a rectangular prism such as this one, it's going to be the area of the base times the height. Kind of like the classic, area of a rectangle formula, base times height, or length times width, however you think about it. Well, this is just 3 of those, length times width times height. So my volume equation is going to say volume equals my length, which in this case is 3x, times my width, which is x, times my height. But I know that the volume is fixed and has to be 320 centimeters cubed. So instead of writing a V there for volume as if it were unknown, I'm going to literally write 320 because that is a known value. So now I want to solve this equation for h because I want to write the height in terms of x. So to do that, I need to divide both sides by 3x squared. So h is going to equal 320 divided by 3x squared. And again, my length was 3x. Cool with that? Cool. Let's go on. Write an equation for the outside surface area of the box in terms of x. Okay, let's do that. But what I'm going to do real quick is I'm going to draw a second box here so we can visualize things that are happening behind the scenes. And when I say behind the scenes, what I really mean behind the scenes. Like, if you think about it, that box is 3-dimensional. So those little dash lines I'm showing you, you couldn't see if you were looking at a real box, but you know they exist. This box has 1, 2, 3, 4, 5, 6 sides. Not just the 3 sides we see here. It has double that. It has 2 of each of those 3 sides that we see there. So let's go ahead and start piecing them together. But real quick, I am going to erase that h there and write it as our expression, which is 320 divided by 3x squared. Cool? Cool. You're right. It is cool. It's super cool. That's neat. So let's go ahead and do this problem. So if you think about the top and the bottom of this box, we're looking at that green bit right there. The surface area of this box is going to compose itself of the all of the surfaces that we have here, which are all rectangles. So my surface area equation is going to equal 2 of these green parts for the top and the bottom. So I'm going to say 2 times that area, which you'll notice is the length and the width of the box. So that's going to be 3x squared, and it's 2 of them. And then I'm going to add to that the area of this side of the box, And again, there are two of those. So that's going to be 2 times the width, x, times this ugly fraction, the height, which is 320. Whoa, that's bad. 320 divided by 3x squared. We'll simplify it later. And then finally, let's add my last side, which is this front and back right here, the yeller feller, which is going to be 2 times, 2 times 3x times, again, that nasty height, which is 320, over 3x squared. Okay, that's the whole thing, but man, that is ugly. So I want to go through and I want to simplify this. So I'm going to simplify each piece, and I'm going to move some stuff around and make myself some room. So I'm going to move, whoa, no, not that. I'm going to do this, like that. I'm going to move that there. I'm going to make it a little smaller because we've kind of used it for what we need. So let's let you hang out there. And I'm going to simplify this problem. So I'm going to go piece by piece. We'll do the green thing first. So again, we're talking about a surface area equation here. And I'm distributing that 2 on my green part. So 2 times 3x squared is 6x squared, plus my red part there, which is 2 times x times 320 over 3x squared. I don't know why I just read it to you. You can read. But let's take a notice at what cancels out. Got an x in the numerator, so one of my x's in the denominator goes away. I could multiply 2 by 320 to make that 640, and I'm actually going to do that and leave it as 640 over 3x, because I still have one x because only the squared part of it canceled out. So that's my red term. And then finally, my yellow term is actually pretty nice, because if you will notice, I've got 3x there, and I've got a 3 and an x there that I can get rid of. So this one is going to become 640 divided by x. So let me get some screenshots for you. Alright, so now we should be at the point where you've entered this function into your calculator, and now we want to graph it and find the minimum value, because 8c asks us to find the minimum surface area of the box. That equation we just wrote is an equation for surface area, so the y values represent surface area. So let's figure out what the smallest one is. But here's the thing, we need to be careful about this. First off, we need to be careful because if you look at how I've entered this, you have to put that denominator, that 3x, inside parentheses. If you don't, you will graph the wrong function and you will get the answer incorrect. Do not forget to put those in parentheses. If your denominator is more than just an x, or your numerator for that factor is more than just one thing, you have to put it in parentheses. Otherwise, your life will become sad very soon. So that's what I did. I put it in parentheses because I like to be happy. And then I did what Mr. Reed normally tells you to do. I graphed it in a standard window. But, oh my goodness gracious, normally that works out terrifically. In this case, that worked out terribly. This graph is horrendous. I don't even want to look at it. In fact, I am going to just erase it. Or that stuff or something, or whatever. I don't know. Who cares? Let's just do the problem. But, here's the thing. We need to think about the context of this problem. Our y values represent surface area. Our x values represent width of the box. So that means I don't need any of this negative x world over here because it doesn't make any sense. The reason it doesn't make any sense is because that is like talking about negative width. There is no such thing. And I don't need this bit down here either, because that is talking about negative y values, i.e. negative surface area. What is that? It's not a thing. So I'm only focused on this quadrant right here, this lovely, magical, positive land. So I want to go there, but here's the problem. In this current window, I don't see my function. Where is it? Where is it? I don't know. This is a weird graph. We've never looked at anything like this before, so I don't know how to predict what it looks like. But here's what I do know. I do know that this is a box. I do know that we're graphing the surface area of the box. I know that the volume of the box is 320. I know that the formula for volume is length times width times height, which in this case is x times 3x times, that weird 320 over 3x squared thing, which I'm just going to ignore for now. Let's just think about that x and 3x. I want to figure out a good window for my x values here, so you can kind of think of it as a realistic domain for my function. Imagine if I picked the x value of 10. Well, I would get 10 times 30 equals 320, and that's before I even multiplied it by the height function. So, whoa, I said 320, that should be 300. But that is already giving us a volume of, clearly it's going to be well over 320, that thing. So that tells me that 0 to 10 for my x window is absolutely plenty, plenty, plenty of x space. Now, the problem is, I already have 0 to 10 right here, and I don't see my function. So, that tells me I need more y. But why, Mr. Reef? Because it's awesome. So let's think about this now. I showed some of you a trick today. I'll show the rest of you it tomorrow in class. But a really good way to figure out what would be a good y value to put in this window range, well, I'm just going to start at 0 just because it's a good place to start when you're talking about real world things. You don't have to. You could use what I'm about to show you to figure out a good minimum y value as well, but I'm going with 0. But here's what you do. Pull out your calculator. Boom, look, I got one. That was pretty cool, actually. I just popped it out of thin air. So, pull out your calculator. If you zoom in here, notice right here is a button that says vars. If you click on it, it will give you some options, and you want to arrow to the right. It'll say function right there. So vars, function, wait, no, what do you do? Is it vars, y vars? Yeah, my bad. It doesn't say function. It says vars. Then you arrow over. It says y vars there. And then the first option is function. Choose function. Then notice it'll say y1, y2, y3. We entered our function into y1. So click y1, and then it will print this on your screen. It'll put that little y1 right there, and then you need to type a parenthesis, and then I want to check my maximum x value of 10. I want to evaluate my function at that value. This is a good way to do that. So again, it's vars, y vars, function. It'll print the y1 to your screen, put a parenthesis, a 10, close your parenthesis, then it evaluates it, and look, 685. Whoa, that sounds like a big number, so maybe this will be a good window for us. But anyways, what that translates to is then if you go to your window, make your x min 0 like we talked about, x max 10, x scale 1 is fine, y min 0. I put my y max at 700 because the value at 10 was 680 something, so I gave myself a little wiggle room. Made my scale a tenth of that difference there. That doesn't matter. That just gives you tick marks on the left. And then I graphed it, and I got this awesome looking thing. So now go through, calculate the minimum value. It's going to get it to you right there. And here's the deal. It's going to tell you that that minimum value is happening when x equals 4 point something something. I'll tell you the real number in a moment. But this is what's awesome. If you're on your graph and you have that x value that you just calculated selected right there, if you hit second and then quit to exit your graph without changing that x value, without clearing that x value, then when you go back to your calculator home screen, if you use the x button, notice right there, that is the x value that you just had on your function that you were looking at. So it tells me the x value is 4.142975334. Well, what does that x value represent again? Oh yeah, it's my width. That's cool, but this is even better. Keeping that x value, I can enter 3x for my length and get a value of 12.429. And then I can enter my super annoying height, which is 320 divided by quantity x squared, and I'm told that that is 18.6434071. And if I multiplied these numbers all together, my number better be super stinking close to 320 cubic centimeters. And I forgot to tell you, but when you find that minimum value, remember again, the question is asking you, I just said axing, it's asking you to find the minimum surface area as well as the dimensions. So remember, we're graphing a surface area function, so our y values represent surface areas. So at that minimum, at that x value we found, the surface area is 308.957. And that's just my calculator telling me that in conjunction with that x value. Sweet!